Welcome to today's video, where we'll explore a common concern that many programmers face when working with functions in their code. Have you ever wondered whether your function covers all return paths, or if it's just the compiler being buggy? This is an important topic because understanding how functions work and what they can do can make a huge difference in writing efficient, error-free, and maintainable code. In this video, we'll dive into the details of what happens behind the scenes. When you define a function, how return statements affect your program's flow, and why sometimes it might seem like your function isn't doing its job. By the end of this discussion, you'll have a clear understanding of functions, return paths, and compiler behavior. Let's start with the basics. A function is essentially a block of code that can be called multiple times from different parts of your program. It takes in arguments, performs some operations, and often returns a value back to the caller. The way you structure your functions, where you place return statements, how you handle errors, and what paths your code can take, determines whether all possible scenarios are covered. Imagine your function as a map with several routes leading to different destinations. Each route represents a path of execution, and where these paths end determines the outcome of your function call. Now, in an ideal world, every path would lead somewhere meaningful, but that's not always the case. Sometimes, you might have paths that seem to lead nowhere or get stuck in loops. These scenarios can happen due to logical errors, missing conditions, or simply because you haven't thought through all possible inputs and outcomes. The question is, does this mean your function doesn't cover all return paths? Well, it's not necessarily a matter of the function itself, but rather how well it's designed. A good practice is to ensure that every path in your code leads to a meaningful, whether that's returning a specific value, throwing an exception for unexpected inputs, or even just ending the program gracefully. This isn't always about the compiler being buggy. More often than not, it's about how well we, as developers, have anticipated and handled different scenarios. The compiler is simply doing its job based on what you've written. So if there are issues with return paths, it usually points back to the design of your function. To make sure your functions cover all possible return paths effectively, take a step back and think through every scenario. Success cases, failure cases, edge cases. Use tools like flowcharts or just plain old debugging to visualize how your code executes and where improvements can be made. Ensure every path in your function leads to a meaningful. Good design is key. Anticipate all possible inputs and outcomes. It's usually not the compiler being buggy, but rather how well your code handles different scenarios. Tools like flowcharts or debugging can help you visualize and improve your code. In whether your function covers all return paths isn't about the compiler's capabilities, but more about how thoughtfully you've designed your code. By understanding functions better and considering every possible execution path, you can write more robust, efficient, and maintainable programs. We hope this discussion has been helpful in clarifying things for you. If you have any questions or topics you'd like us to explore further, please leave them in the comments below. Don't forget to like this video if it's helped you, and consider subscribing for more content on programming and software development. See you in our next video.